Read the question. One meter, 0.5. This wall will not be there. It's a diaphragm, means which can vibrate also. Let's take like this. So there's a tuning fork. No, this can vibrate. This is a fixed. How the energy will propagate? We'll assume some small gap I given. So that is enough. From there, open the sound energy can be fed into this chamber also. So if completely closed, then why wave will propagate? Not possible, no? Emitter. So yeah, small hole, that is enough, that one. Through that open, the energy can feed into this particular chamber. So I think in exam, you have to be a little bit careful. So close means, okay, sir, why here? How energy will flow here? Small gap, or you can put over here. So through this hole open, the energy can flow. So actually we know sound wave, no? So actually it'll come like this. If small hole is there, it will be like a source. So from there, then get reflected. So just take help of the basic diffraction phenomena. Let's not go into much depth. So if I show it here, let me show what happened. Let me show at the middle. It'll be easy for you. There should be some small gap through which open the sound can be fed to the second chamber. Okay, no, he's asking. This can vibrate. So this should be displacement antinode. This should be node. This should be node. Will I agree this? So there are some, so as it is. So don't bother anything about all. That's what I'm telling. You need to bother that one. And let there be some. Just for your understanding purpose, I'm showing the loops. So N1 loops, let it be here, N2 loops. So we know length, this is L1, capital letter L1, and this is L2. Okay, I think you go back to the two ropes joined. So what we can write it now, L1 plus L2. Or this L1, what we can write, lambda 1 by 4, N1, lambda 1 by 2. Similarly, L2 should be equal to N2 lambda 2 by 2. Do we know lambda 1 frequency of the fundamental frequency of the combined system? Tuning fork approaches the wall A with a velocity. He has given that velocity also. What to do with that velocity?
We can find lambda 1. We can find frequency at that diaphragm.
Speed of sound we have here, no?
Doppler effect.
Doppler effect.
The diaphragm will act as secondary source and produce waves inside the chamber.
That is say actually,
Frequency of diaphragm and tuning fork should not be same.
okay, they're in resonance, no? Finish over. The tuning fork will be vibrating and is also moving.
So we should take Doppler effect.
So the waves will come like this. The waves will be propagated. So now what happened? This is from moving source, it is being generated. Then frequency of this particular waves that is received by the organ pipe. What is the state of organ pipe? Organ pipe is fixed. Okay, the frequency what as the wave propagates from one medium to another medium, frequency will not change. We know it. Speed of what is V1, V2? Speed of sound in that medium, in this medium and this medium. So definitely the wavelength is going to change. So what is the frequency of the waves that are emitted? Will this diaphragm will receive at the same frequency or different frequencies? So let the frequency of tuning pole, let it be F naught. The organ pipe is going to receive at this one. So now I think we'll go for Doppler effect. Speed of sound given.
No, sir.
Okay, no, okay, don't touch Doppler effect then. If you give speed of sound, then we would have taken something.
We can take 330.
Okay, better if you give speed of sound, then take Doppler effect. Otherwise, leave it. So lambda 1, what we can write it as V1 by F naught. Lambda 2 as V by F naught. And L1 plus L2 we know. Write it and check for what can be the possible things.
Sir,
Ah,
then what is the significance of U?
I don't know, like unnecessary is troubling us. If you give speed of sound, okay, I would have taken Doppler effect since he didn't mention. No? So what all, even if it is at rest and vibrates, it will produce sound wave. It doesn't mean that it should move. If you just move, we don't get sound wave generated. It should vibrate, then only we get sound wave. I think I'm right. The prongs should vibrate so that what happen, the disturbance will be set up. If the tuning fork, if you move, what happen, no disturbance will be set up. Maybe you wanted to confuse us through this U. Okay, let me write next step. Lambda 1 will be we know length L1 plus L2. The frequency must be same in both the chambers. No? So the displacement already I wrote it. Okay, what to do now? Fundamental frequency from where to bring. This F naught has to be determined. No?
We'll substitute N1 equal to 0 into equal to 1 and we'll find.
N1 0 possible. Huh?
Fundamental.
N1 0. What about N2? How much you get? Yeah.
N2 equal to 1. We'll substitute those values to get fundamental frequency.
N1 equal to next value.
Both will independently change.
No, yes. Next set of values. Huh? I just wanted to. N1, 3 and 11. Okay. Yeah. No, I think we'll go for higher things. Huh? Okay, now next. Which one we have to pick up answer? N1 equal to 0, did we substitute anywhere?
Sir, that first one is wrong. What I told is wrong.
Wrong. Not possible.
I got the relation 3n2 plus 11n1 equal to 22. We should find n1 and 2 which satisfy that equation.
Yeah, that one. Okay, I think this is not possible. This is correct. N1 3, N2 11. We have to just make a guess of values, which will satisfy the equation.
n1 1, n2 11.
N1 1 and N2 11. How it is possible?
I substituted L1, L2, V1, V2 and I got a relation between n1 and n2, sir.
Both cannot be correct, no?
3 and 11 is not satisfying.
3 and 11 not satisfying. So who is right, who is wrong?
You solved, sir, once.
N1 1 and N2 11. Okay, yeah. N1 equal to 311. Okay, the one is right, one is wrong. Let me check with the option first. More than one correct. 21 ACD is given. I don't have any N1, N2 like that. Only we have options like ACD as given. First chamber is in third harmonics. Second chamber is in 11th harmonics.
Three and 11 is not satisfying, sir.
So 3 and 11 is not satisfying.
1 and 11 is satisfying.
111. So first chamber is in what we should call fundamental tone, no? Okay, third harmonic. Yeah, correct. Okay, then it will be, yeah, this will be correct. Then. What do you mean by third harmonic? You should say first harmonic, no? Half loop is first harmonic. Only odd harmonics are present. So the fundamental tone is first harmonic. First O tone is third harmonic. So I think it's correct. Okay, I think there's a real trouble thing. A third harmonic will think that 3.5 loop or no, third harmonic means 1.5 loop.
Sir, can you tell C and D options again?
What you're saying?
Why is C option correct, sir? Third harmonic.
Third harmonic means, say, first harmonic means half loop. Third harmonic means what happened? 1.5 loop. It's a closed end organ pipe, no? AB will behave like a closed end organ pipe. BC as a both ends closed. So AB is a closed end organ pipe because there's a displacement antinode, there's a node, no? So closed end organ pipe, first harmonic half loop. Third harmonic is 1.5 loop. And we have N1 1. So 1.5 loop, it will start. It will start with 1.5 loop, next further value. I think what he's saying third harmonic is justified, or you should have said first tone, first O tone. But N10 not possible. That we are very sure. So I think the giving number, keeping closed end organ pipe is giving these things. Huh? This one. For explanation, I just drawn 3.5 loops. It is in the actually 1.5 loop. It will start with 1.5 loop. Here we'll get 11 loops. Again, you can go for next fundamental tone will start from here, 1.5 and 11. Next, again, you can keep on increase the number. Okay, justified. Shall I go for next one?
Sir,
Yeah.
Sir, if you are taking only odd harmonics for the first chamber, why are we taking Order harmonics for the second chamber.
No, so this equation is putting conditions here. That's all. 1.5, 11 loops.
I'm talking about white. If we take C option, then we shouldn't take D option.
No, no, like you see that one here, like a
Yes, sir, understood.
closed end organ pipe will start from all, no, first harmonic, second harmonic, third harmonic, fourth harmonic. In closed end organ in like a both ends closed, all harmonics are present. Closed end organ pipe, only odd harmonics are present. Getting the idea? I think it's really troubling us a lot with this terminology here, nothing to do with concept. All harmonics are means all harmonics means I should not say like that. Here 11 loops are there, no, I'll call 11th harmonic here. Half loop first harmonic, 1.5 loop should be third harmonic, not second harmonic.
Okay, sir.
There's a terminology. You can just say don't consider any Doppler effect. Neglect Doppler effect. Tuning fork without vibration moving towards the organ pipe will not produce any wave. It should vibrate, then it will produce here.